All right, let's dive right into social choice theory. We're going to break down exactly what you need to know to absolutely nail this on your upcoming exam.
So, here's the game plan. We'll kick things off with the fundamental problem we're trying to solve. Then, we'll walk through 4 key voting rules you've got to know. After that, we'll see what happens when those rules clash, look at how to judge them fairly, and then tackle the big one, the impossibility theorem, before wrapping up with your key exam takeaways.
Okay, first things first. What is the central question of social choice theory? It's really this. How do you take a whole bunch of individual preferences, all the different things people want, and combine them into a single, fair decision for the entire group?
Now, to get this right, you have to understand a crucial assumption. Other economic models might assume we can measure how much someone wants something. But in social choice theory, we can't. We only know people's rankings. What's their first choice, their second, their third. We don't know the intensity, and we can't compare my happiness to your happiness.
So, if all we have are preference rankings, how do we actually make a decision? Well, we use voting rules. And for your exam, you absolutely have to be fluent in these 4.
First up is the one you know best, the plurality rule. It's super simple. Whoever gets the most first-place votes wins. You see it in tons of elections. But here's the key drawback you need to remember. It completely ignores what people put for their second, third, or fourth choice. All that information is just thrown away.
Next, we've got the Copeland rule. The best way to think about this is like a round-robin sports tournament. Every candidate goes head-to-head against every other candidate. We see who wins each matchup, and the one who wins the most one-on-one contests is our Copeland winner. It's really good at finding a candidate with broad, not just deep, support.
Then there's the border rule. Now, if plurality ignores most of the ballot, Borda does the exact opposite. It uses the entire ranking. You get points for each rank. Maybe 3 points for first, 2 for second, 1 for third. We tally up all the points from all the voters, and whoever has the highest score wins.
And finally, we have instant runoff voting, or IRV. This one is like a series of elimination rounds. In round 1, we find the candidate with the fewest first-place votes and knock them out. But their votes aren't wasted. They get transferred to each voter's next favorite choice. And we repeat this process until one candidate is left with more than 50% of the vote.
Okay, here's where this subject really comes alive. We have these 4 different tools for making a decision. You'd think that if you use them on the same group of voters, you'd get the same winner, right? Well, not so fast.
Let's look at this election. We've got 13 voters and 4 candidates, A, B, C, and D. Take a look at how the preferences are spread out. You've got a group of 6 voters who love candidate A, another 4 who think D is the best, and so on.
Okay, let's run the numbers. First, using the plurality rule. It's easy, right? We just count the top spot. A gets 6 first-place votes. C gets 3. D gets 4. So, with 6 votes, A is the winner. Simple. But wait, let's switch to the Copeland rule and run those head-to-head matchups. When you do that, it turns out that C beats A, B, and D in one-on-one contests. So under this rule, C is the winner. A completely different outcome.
Okay, how about the border rule? Let's give out points for each ranking, add them all up, and, believe it or not, candidate B comes out on top with 22 points. So now B is our winner.
And for our last one, instant runoff. In the first round, nobody put B first, so B is out. In the next round, C has the fewest votes, so C gets eliminated. Now those 3 voters who had C first, their votes now go to their second choice, D. That pushes D up to 7 votes, which beats A's 6. D is the winner.
So let's just stop and think about this. This is kind of wild, right? We had one group of 13 voters. We didn't change a single ballot. But by applying 4 different and totally legitimate voting rules, we got 4 different winners, A, B, C, and D. This is the absolute core problem. If the rule you choose determines the winner, how in the world do you decide which rule is the best or fairest?
Well, the way we try to answer that is by using a set of principles we call axioms. Just think of axioms as basic, common-sense standards for what fairness should look like. We can then test our voting rules against these standards.
For your exam, you need to know these 3. First is anonymity. This just means a vote is a vote. It doesn't matter if it comes from a king or a commoner. Second is neutrality. This means the rules don't favor any candidate from the start. Swapping their names around shouldn't change the result. And third is positive responsiveness. This is pure common sense. If an option is already winning and it gets even more support, it should definitely still win.
Now, these axioms lead us to a very powerful result, known as May's theorem.
It proves that simple majority rule is the only voting system that satisfies all three of those fairness principles. But, and this is a huge but, it only works when you're choosing between just two alternatives. The minute you add a third option, things get messy.
So what happens in the real world, where we almost always have 3 or more choices? Well, this leads us to what is probably the most famous and, frankly, mind-blowing discovery in this entire field.
So, the economist Kenneth Arrow came up with 3 conditions that seem incredibly reasonable for any fair system. 1. Weak Pareto. If every single person prefers X over Y, then the group as a whole should prefer X over Y. Simple, right? 2. No dictatorship. One person's preferences can't just become the group's preferences. And 3. Independence of irrelevant alternatives. This means the group's choice between, say, chocolate and vanilla ice cream shouldn't suddenly flip just because strawberry becomes an option.
Okay, get ready for the bombshell. Arrow's impossibility theorem proves, mathematically, that when you have 3 or more alternatives, no voting system can possibly satisfy all 3 of those perfectly reasonable conditions at the same time. It's impossible. Every single system has a flaw. There is no perfect voting method.
Okay, to really make sure you've got these concepts down cold and are ready to ace that exam, you can find a complete summary and a bunch of practice tests over at gradeguru.nl.
All right, so let's lock in your exam takeaways. Number 1, social choice theory is all about making group decisions when you only have ranked preferences. Number 2, the voting rule you choose isn't just a detail, it can completely change the outcome. And number 3, Arrow's theorem is the big one. It proves there's no perfect voting system for 3 or more options. Every single one involves some kind of trade-off.
And that leaves us with this final, really big question. If we know that every system is flawed, the challenge isn't about finding a perfect one, because that doesn't exist. The real debate is about deciding which fairness principles we care about most and which flaws we as a society are willing to live with.